Today we're going to be going through the methods of calculating out your OOIP and OGIP calculations through GeoAtlas. Kind of two methods of doing that. We're going to kind of run through both of them. So like I said, the two methods of calculation here we're going to be looking at. One's going to be run through grid operations, the other through the volume and area statistic tool. This tool kind of added in a new feature, one of our previous releases put out in the last year or so, where you can plug in a particular grid and calculate out the OOIP data directly. But we're going to go through the old method as well, running through that grid operation. So the grid operation allows the input of grids to run the calculations. You plug in an equation and you define each variable in that equation with a grid. So we'll build an equation there and plug in a couple of different grids into it. The other method there, the volume and area statistic tool, calculates based on a single grid input and variable definition. So this one we're going to run through a SoPhiH grid to calculate out some of that data and plug in a couple of variables. All right. So yeah, workflow, we're going to create an OOIP calculation from grid operations. This is going to input in some average water saturation, our average porosity, and a net sand thickness grid to plug into this equation, and then we'll calculate it out through volumetrics. We'll also look at the OOIP calculator in that same volumetrics tool, where this time we'll just input in the SoPhiH map to run through the calculation. And our SoPhiH is going to be calculated from Petrophysics. Below the equation we'll be running here, area times height times our conversion factor times porosity times 1 minus water stat, all divided by a volume factor. So we're going to plug in a couple of variables into that equation and run through it. And so we'll be using both of those methods as we do that. All right, so let's go ahead and jump right into it. We're going to start first directly in Petrophysics. So like I said, we're going to be starting off from kind of calculating out the water sat, porosity, and some net sand values to kind of plug into that equation within GeoAtlas. So I've got up here right now just a template with my Archie interpretation, Archie UDE running through here to calculate out my water sat curves and everything else I want to calculate from. And you can see here, this is just the standard Archie interpretation equation set that we've already got pre-built into the system here. So phi calculating out to give me some various other curves down here at the bottom, phi e, which is then used for RO, or for water sat, for BVW, and then for my SoPhiH. So this is going to be the curve that I'm going to plug into the OOIP calculator later on. We're taking an average of this, no, sorry, not an average, a sum of this over our given interval. And then a water stat average and a phi e average here for the other grids to plug into grid operations. So these are our input curves and our output curves that we've generated from the UDE. And as you see, I've got them displayed over here in the template. And the interval we're going to be calculating over is highlighted here in the red, F11 to F11 base. Kind of our main area of focus here, our thickness that we're mainly calculating over is from that particular interval. So when I calculate this data, I want to make sure I calculate over that particular zone. Now, I've already got the zone set up here for me. F11 zone has already been defined, F11 to F11 base, and I've got a couple of attributes already calculated out here for me, but we'll run through how I calculated those and got those values. I've also already got the grids generated for some of these when we go over to GeoAtlas. Those are already built, but again, I'll kind of just walk through how I created those. So we're going to start first by getting those grids we want to plug into the equation. We're going to run through that in the curve data statistics. So here in Petrophysics on the interpretation tab, curve data statistics here. So we're going to calculate out three different statistics from here. One, we're going to run through our phi e curve, calculating out the average for that. And we'll do that over our given interval. So I'll choose my F11 zone. It's already got F11 to F11 base here. So we'll add that one over. I'll do another one for my water sat over that same interval, again, calculating out an average. And then we'll do one for my SoPhiH. For this one, we're going to sum. Now there's kind of two options there, sum and sometimes height. I've already factored in the height part of the calculation in the UDE. I just want to make sure I don't double up on that height calculation to get bogus values. So just be aware, depending on what your UDE is running, if you've chosen to calculate a height, in this case, it's a step calculation. If it's already been calculated in the UDE, you don't need to run it here again. We can just run the sum. But again, SoPhiH sum over my given interval, and I'll add that over as well. So 3 parameters I'm calculating. As you see here, I've got a filter applied. This filter is looking for wells that actually have some of my input curves. Any well that doesn't have that, then I don't want to include that in my calculation, as they just come back with a bunch of nulls. So I've filtered out 14 of the 20 wells I've got selected here, have the data that I need. 6 wells have null values that I'm ignoring. So with these 3 parameters, I'm going to go ahead and create the data, run those statistics, and then I'll get my values. So from here, I can go through and start QCing some of the values, make sure they seem reasonable, start looking for any outliers, figure out if there are any issues with my input data, any issues with my calculation. Do I need to go back and check through some of that to figure out what might be going on there? I think I see a bit high values with some of my water stat, but we'll run with that for the purposes of what I've got here. And then my SoPhiH calculation over here on the right. So from here, typically what you would do is you can save these out to Zone Manager. Once they're in Zone Manager, saved as an attribute, then I can post them on a map. I can build grids based off of them. I can also go directly into building isomaps directly off these values right now, create isomap layers from here. But then if I needed to come back to use these values for something else later on, I would have to go through here and recalculate all this. Now for these 14 wells, didn't take all that long to do, but when you're going through there and doing a lot more wells than I'm probably doing here in your bigger, much more larger projects, it takes a bit more time. So that's why it's a good idea to have those available in Zone Manager as an attribute so you can recall them later on. So to do that, you'll simply save to Zone Manager, choose the parameter that you're calculating, the zone that it's going to be saved to, then the attribute that we're saving it to. So then I can calculate that out as my my average fee. Like I said, I've already got one calculated there. I also have an effective fee I can put it into here. Those 2 parameters. Again, already calculated out and saved in there right now. But essentially, you just choose which attribute it's going to, and you save the zone and attribute names, and you'll set that for all 3 of these, whatever it's going to. Average water set, and here's my hydrocarbon pore thickness, SoPhiH here. So you kind of choose the attributes. Once they've all been saved, you'll save those out to Zone Manager, and those values should then populate there, again, for use in mapping purposes or anything else you want to do with them. Then you can go over to Zone Manager and check the values to make sure they've all appeared over there. I'll go ahead and pull up a little spreadsheet here with all the data here. Let me just make sure. Oops. I want to look at those 3 attributes. So that was my, actually, no, it's my effective fee, my water set, and my hydrocarbon pore thickness. And so I can see here the values that I have for each of the wells there. And again, I've only calculated this over the 14 wells, so I should only have 14 values and 6 nulls down below that we didn't calculate. So those are the values I'm working with here. I can see they're here in Zone Manager already. Like I said, your other option is you can go directly just to creating the isomap layer. Same kind of thing, you just choose which parameter you're building, give the layer a name, and you'll go through and just build out some of the grid information. Smallest feature radius, are you going to be using a boundary polygon? Are we kind of plugging in, changing any of the contour interval information? Are we plugging in any color fill into that? Similar kind of options you see whenever you create an isomap layer. I'll just pull up the menu here. To create an isomap layer before, looks exactly like you've seen. Plug in your your build parameters to adjust grid spacing, anything else you need to do there, change your contour interval, apply a color fill, apply a boundary polygon. Again, I've already got some of these created, so I'm not going to create another one right now, but same process applies for creating any ISOMAP layer. All same options apply there. So then you just do that for all three of these, build one for your VE, build one for your water set, build one for your SoPhiH. And then with all those grids, then we can go ahead and plug those into the grid operations. So this is where our data that's going to be plugged into this equations is coming from. We've calculated that from our petrophysical data using the curved data statistics and my input UDE from my Archie interpretation to get my water set, to get my porosity, and to get my hydrocarbon pore thickness, which I'll be using later on. Okay. So all that is calculated and created, so now I can use it in other places. Now one other piece of the puzzle is that net sand, kind of the thickness that I want to plug into that equation. If you remember before, calculation was A times H times that recovery factor times our porosity times 1 minus the water set. So our A value is going to be factored in from the polygon that I choose to do the volumetric calculation on. The H, that thickness, is going to be coming from a different parameter. I'm going to jump over to cross section here. Just kind of showing again, the main area that I'm looking at here is at F11. So I've kind of got that highlighted here in red again. So that's my main thickness area that I'm looking at, but I'm calculating out a net sand within that. So I've got that highlighted here in blue. This is an interval picks that I've done on this well, on a group of these wells. Kind of zoom in here. Where I've taken a sandstone fill from the template that I have here to show where my sandstones are, given, based on a gamma ray curve. And I've just gone through and I've selected where that sandstone starts and stops to figure out a net sand for each well. And I can see the thickness calculated from each of that. So 27 feet, 6 feet, and on the way all through all these wells. Now I picked it in a couple other places here as well. This is outside of the zone, so it's not considered in my calculation. Main thing just being that as long as I have a sandstone pick between these two tops, that'll be included in Zone Manager. And then once it's in Zone Manager, I can build a map of it. So net sand's been picked through here. Again, this is using the interval picking tool. And just kind of show how intervals are picked. Choose the interval you want to pick. In this case, I've got a net sand. See, there's a couple other ones in there. If you don't see the one you want to pick, you can create it. Just give it a name there, whatever you want to call it. Once the interval is selected, I can use this tool to go through and pick over that interval. Simply click and drag to pick the interval, or click once to start it, click once to stop it, pick an interval there. Again, these are outside my zones, so they won't be considered in my calculation. Once I save this data, I can kind of choose how to save it, if it's over a specific zone or just over the entire well. So again, all that picked in each of these wells, and there's a couple of wells that don't have any net sands. No sand in this area, so zeros. I put a 0 marker in there to indicate that there's no data there. I could also leave it blank, but that would come back null, and I might forget coming back to look at it later on. Wait a minute, this well doesn't have a net sand. What's wrong with that? Go and look at it and realize, oh yeah, it's a 0. So I put a 0 value here, so I know there is no sand in there. So yeah, that's been picked. Oops, looks like I missed one. Picked across all the wells here within that particular zone. I think it's because I adjusted the information top on that at one point. In any case, got that picked across everything, so we can go through and save that interval data. Save button there at the end of the interval picking tool. Save the data to the Zone Manager. And I can plug that here directly into my F11 zone. I can calculate the well zone too to pick up everything, even the stuff outside of those two picks that I did before. But I'm mainly just focusing on the F11. So that data gets saved and brought back over into Zone Manager. And I can pull that up over here to look at it. That is my net sand. There it is. I should see all those values calculated there now. So an extra well there that didn't have any of this other data, so it's not really going to be used too much in some of my calculation, but I can use it for the gridding purposes. So again, all these values now plugged into Zone Manager. Once they're in Zone Manager, I can see the data there, and then I can go ahead and build a map off of it. And those maps, those grids are going to be what I'm plugging into my volumetric calculation tools. So we're going to jump over to, let me go and close this cross section as I don't need it anymore. No, I don't need to save it. And then we're going to jump over to GeoAtlas. So GeoAtlas, this is where I'm going to kind of go through and actually calculate out my OOIP data. Starting off first, like I said, with the grid operation. So I've already got a couple of these grids built. Again, kind of saw you can do that from Petrophysics, or you can build them out from a Zone Manager source, Contour IceMap built source, or built surface. Choose your data sources from the Zone Manager data, and then get those grids created. So just to kind of show some of those grids, it's my PHE grid, again calculated from the PHE attribute. I've limited everything to this boundary polygon, mainly around my well data. I got a bunch of other space out here that doesn't really have any data. So I'm trying to limit everything to where I actually have data. So everything's bounded to this, and everything's using the same boundary polygon there for that information. So there's my effective porosity grid. There's my water stat grid. And there's my net sand grid. So those are the three grids that I'm going to go ahead and plug into the grid operations. And then I also have down here a hydrocarbon pore thickness grid, and this is the one I'm going to use later on for the OOIP calculator. So again, everything is kind of clipped and contained to the same area. And those three grids, like I said, variables I'm plugging in here. So let's go ahead and build out that calculation. Go to Contour, IceMap grid operations, second option here. And then we can build out our equation. So the equation that we're going to be using, I've already got it saved in here. Go to my equation editor. This is going to be a calculation for my recoverable oil, which I'll find down here somewhere. Here it is, recoverable oil. Select that and plug that in here. So this equation, I have A times B times 1 minus C times a 0.3 recovery factor. Again, going back to that equation that we looked at before, this is essentially what I'm plugging into here. I can also put in my conversion factor value in there as well. I'm just going to be kind of, well, yeah, I can plug that into there, that's 7758. So this is, A is going to be coming in later on when I do the actual volumetric. So right now, A is going to be my height through my net sand. B is going to be my porosity. C is going to be my water stat. And then I'm just kind of not taking in any confirmation factor in there. To kind of get my recoverable oil, and then I'll take that and plug it into volumetrics, which will be based on an area, where I can choose a specific polygon. That polygon will have an area, and then I'll calculate from there. Okay, so that's my equation. Now I just need to go ahead and kind of determine what each of these values are. So like I've said, A is going to be my thickness there, that H. That's the net sand thickness. So I'll select that grid. There's the net sand, and apply that to A. For B, so that's going to be my porosity grid. Select, and I'll pull in my PHE. For C, my water set, I'll go ahead and choose that from the water set grid that I built. So all three of those variables are now defined. It's pulling the grid values, each of those grid values, and plugging it into that equation, multiplying it all by 0.3, that recovery factor. And from here, just for grid operations, I need to define one of these as a key grid. A key grid basically determines what grid spacing, what boundary polygon area, kind of the clipping area for a lot of your data that you're going to be using. It's going to pull from that particular grid as source, essentially, to apply all that. I don't really have the same options that I do for my build surface layers, where I'm determining all that plugin information, your smallest feature radius, all that other kind of stuff. From here, I'm essentially just kind of going through and picking it myself. So all three of these grids are essentially built the same way. They all have the same smallest feature radius. They all have the same boundary polygon. They're all kind of covering the same area, so my key grid doesn't matter in this case. All three of them are essentially the same. So I'll just take the first one, set that as a key grid. But you will need to kind of check that yourself. Just be aware. If all three grids have different grid spacing and all that kind of stuff, use the one that you want to apply here. Click next, and so I'll see the grid settings and key grid. Extent information, again, is dependent on the key grid. So my columns and rows are based on that. So 100 bin spacing here for my XY grid spacing. Again, all three had the same, so that should work okay there. We'll go ahead and name this. This is my recoverable oil layer. I'll run through and run that grid math over all those grids, generate my output grid here. And then from here, I can go ahead and figure out, is this the contour spacing I want to use? I might want to drop that down a little bit. We're going to go from 0 to 0.75. And we'll go at about a 0.05. That should be fine. I can apply a color fill to this if I want, all the other kind of usual stuff. I don't need to set a boundary polygon this time. Boundary polygon's already been kind of set from the key grid information. So I don't need to build another one in this case. We'll see the outputs here is basically going to limit it to where the data was. So we'll go ahead and hit finish. And there is the grid. As you see, no boundary polygon needed. It just went to whatever the extents were. There's the boundary polygon that we pulled from. This is what my VE grid in this case. That's going to be what's limiting the data there that I'm seeing. Okay, so there is recoverable oil. So now that is the information that I want to plug into my volumetric calculation because we still need that A part of the equation. So whenever you do volumetric calculations, you need to do it over a particular polygon. It has to be a closed polygon that covers the grid. So this can be a contour, this can be a township or section block, it can be a lease block, or any other hand-drawn polygon. So I can take one of my grid polygons here. This one I see right here. I can take one of these closed contours. We can draw my own polygon. I'm going to take this one that I've got, covers the grid. That should work. So once you select the polygon you want to use, and I can do multiple polygons as well. And again, I can see another way I can select other polygons here in just a minute. Right click, and I'm going to choose the option down here towards the bottom, volume and area statistics. So with my volume and area statistics here, I can plug in the source grid. I'll use that recoverable oil one I just made. This is just a kind of normal grid type here. You'll see it's thickness map. That's kind of the only option. It's not necessarily a thickness map, but basically just indicating that this is calculated from my grid operation data here. And we'll see when we get into the oil reserve and gas reserve options. You'll have a couple of different grid types to plug into there and how they come into play. But I got the grid I want to input, the polygon that I'm going to be outputting to. You'll see right now these names are based on just the polygon types that I've selected here. We're working on the feature to add into here so you can kind of better name some of these as they come out as opposed to just polygon tracked, just generic names like that. So when you select multiple polygons, you can kind of differentiate them. I can come in here and rename it myself, but you'll have to do that kind of one at a time and then it'll revert back each time that you calculate it. So again, we're working on an ability to make that a bit easier to work with. Right now, again, I'm just going to keep this as tracked. And like I said, I can come through here and I can select other polygons. Each polygon I kind of click on here. I'm highlighting it. I can also control click to add multiple polygons to calculate across. And move that over and just pick up that other one that I had before. So I got multiple polygons selected here. A couple of these I want to be kind of careful with. They're bigger than my grid. So that might affect values there. So I may want to go through and remove some of these if I don't want any of those selected, just depending on if it covers an area or not. So that's fine. We'll work with these two here. And then down below I'll have my area. We'll see here an area right now. This is in acres. I can do it based on square feet. I can do it on kilometers, or square miles, square yards. A couple different options you can kind of plug into there. You'll see total area here is 0.35 based on the 0.2 and the 0.15, two different areas I've selected up here at the top. And we'll go ahead now and calculate out that volume. So it's saying anywhere that my grids go negative, so you want to just set those to 0, as we don't really intend for any of that to go negative. So we'll go ahead and click yes on that and do it for both of those. And there is the volume calculated from that. So there's my total volume in barrels, and again, I can change that to different units here: gallons, cubic yards, BCF, MCF, kind of figure out those values. And from here, then I can copy this data to clipboard, or I can save this out as a text file that I can then share with anybody that might need that information. Okay, so we'll go ahead and close that. So that's for recoverable oil. That's my grid operations layer. Again, plugging in my various grids that I want to build that layer based on. Next one we're going to look at is all based on just a single grid. And that's my SoPhiH grid here, my hydrocarbon pore thickness grid, and do a similar type of thing here. So given this particular grid, again, I'm going to take these 2 polygons, and let's throw this one in as well. These 3 polygons here, right-click, volume and area statistics. So same way I just did before, but this time I'm going to go directly to my oil reserves tab. So oil reserves tabs looks a little bit different. You can all see the 3 polygons I've got selected here, and I can plug in my source grid. But I want to be aware of the grid type that I can select here. So you have 3 options. You have a thickness map. So that's going to be the H part of your calculation. So if all I have is a thickness map, so I have area factored in from the polygon, I have H figured in from the thickness map, I plug into it. So now I'll just need to define a porosity, water sat, and any other kind of formation volume factor or recovery factor values. So these are just going to be constant. So it's not like I did before the grid operations where I can plug a grid into this, base it off that grid. These are just going to be a constant value. So I can take an assumed, say, 30% water sat over an area. I'm sorry, that's porosity. 30% porosity, we'll say, I don't know, 45% water sat. Just a 1 for formation factor. This is the BO value on the denominator in that equation. So that plugs all those constants into that equation and then takes H based on whatever source grid you plug into it up here, whatever that thickness is going to be, and then runs that calculation. Now let's say you've already calculated out porosity data. Well, then I also have an option for a SoPhiH map. So porosity and height have already been factored into whatever grid I plug into that. So if I had a SoPhiH map, then I would just need a water saturation constant. So I can plug in whatever constant I want to plug into that, whatever recovery factor I'm going to use, whatever formation factor I'm going to use, and that runs it into the equation and calculates out the OOIP data. And the third option is your SoPhiH. So at this point, porosity, water sat, and H have already been calculated. So I don't need to plug in any constants here pretty much. It's just going to be your areas you selected for each polygon. And then same things, your formation factor and recovery factor values. And so here I'll choose my hydrocarbon pore thickness grid. So that's already factored in porosity and water sat and the height. Area coming from the polygons and everything else plugged into here, so I can go ahead and calculate out my oil reserves from that. So within each polygon, I'll see there's my average SoPhiH, OOIP, and ROIP. And again, different, what am I trying to say there? Units for selecting their barrels, million octane barrels, 1,000 octane barrels, cubic meters, 1,000 cubic meters, million cubic meters. So however you're selecting to kind of represent those values. Again, various different drop downs there. Areas and acres, and we can do our square miles there. So all that data is just coming directly off that SoPhiH map. So I don't have to plug in or build out that water sat or anything else. It's already been calculated from Petrophysics in that SoPhiH calculation. So I'm only plugging in one grid here. Now again, some things we're looking at doing is the ability to plug in grids in here instead of constants. Again, if you're just plugging in a thickness, much like we saw with the grid operations. So you can kind of get a higher degree of accuracy with some of that as opposed to just plugging in those constants. So that should help out with some of that as well. And again, we're looking at adding that in the future release. And then gas reserves calculated much the same way. Same kind of calculation stuff. You're just plugging in the type of grid, VH, SoPhiH, and then calculating out your OGIP data. So hydrocarbon pore thickness, SoPhiH, your formation volume factor is going to be, and then calculate out my gas reserves. Okay. And again, same thing with the other one. I can save this data out into a text file, copy it out to clipboard so I can paste it into something else. Basically taking this data that I see up here, and the same as renaming each tract there as I do that. And like I said, we'll work on some ease of use options there for renaming some of those, so it just pulls from a data type in each one of those polygons as opposed to just the generic polygon name. Yeah, so that's essentially our OOIP and OGIP calculation methods. Kind of two different ones you have there. So I think a lot of people like using the grid operations because you can plug in the variable grids directly into that equation as opposed to the constants that you plug in over here. But whatever one kind of works better for you there, the two different options for calculating that data out.